Good morning, students. We will continue the previous class. In that previous class, I was saying you about the power of accommodation of the eye. There I was saying you about that lens formula. 1 by f is equal to 1 by v minus 1 by u. There I said, when we discussing here, there I said that image distance was fixed. Okay. As the object distance changes, there should be some change in the focal length of that lens. See, look here, what it means. Now, here there is a marker. Now I can see it clearly. Means what? From this my eye, that marker is at certain distance. Here there is a particular object distance. Now I can able to see it. Means what? The image of this marker is exactly produced on my retina. So there is a signal to my brain as there is a marker. Have you understood? I mean, for this particular object distance, my eye has one particular focal length for that fixed image distance. Getting what I mean to say? Now, if I look on this object, right now both are there. When I look here, I can able to see. Here there is a different object distance, then my eye has a different focal length. Now when I look on this marker, black marker, now also I can able to see this black marker. Mean what? Now also the image of this black marker is formed on my retina. But what is difference here? Here when I look on this blue marker, I can see here this blue marker is close to my eye. I mean here object distance is less. It is too far. This object, I mean this black marker is too far. I mean object distance is more. U is greater in this black marker case. Now also I can able to see it. I mean object distance got increased. When I look here, I can see. Means what? Its image formed on my retina. On that fixed image distance, I got the image of this black marker. What happened? I increased. By looking like this means what? When I look on black marker means what I increased here? Object distance increased. That black marker is too far. When object distance got increased, even I can see at that time means what? Automatically that my eye lens got increase in its focal length. That my eye lens got increase in its focal length. I mean the focal length of my eye lens got increased. How? Automatically it got increased. If I look on for object again, for object means now which distance got increased? Object distance got increased. Now also I can see that for object distance increased. Even I can see that means what? My eye lens focal length also got increased. I mean what? When you look on a different body, when you look on different positionally placed body, you can always see their image on retina. What happening there? Automatically there is a adjustment in focal length of our eye lens. Already I said according to lens formula, this our V image distance is fixed. When we change object distance, there should be a change in focal length. Yes, if you increase the object distance, focal length is also going on, increases. Increasing object distance means what? See here. When I looked here on this blue color, object distance was less. If I look here on this one, it is too far. Means what happened here? Object distance got increased. If I look from black marker to blue, black was too far, object distance is greater. If I look here, then object distance what? Decreased. If you increase or if you decrease that object distance, their focal length is also going to adjust automatically. This is happening inside our eye by the part called as ciliary muscles. These ciliary muscles are going to, I already said, this is a biconvex lens, this is our eye lens. At the top and at the bottom there are ciliary muscles. These ciliary muscles are going to stretch that your eye lens, or they going to compress that your eye lens. By stretching or by that compressing that eye lens, those ciliary muscles are changing the focal length of that your eye lens. That eye lens is flexible. It is in a normal eye, that eye lens is flexible. That's why those ciliary muscles are stretching and compressing that eye lens. By doing like that, those ciliary muscles are changing the focal length of that your eye lens. This is happening automatically. Getting what I mean to say? Yes, this ability of this eye lens to get the sharp images of distant object always on retina is called as power of accommodation of the eye. Have you understood what I mean to say? When you look on near body, at that time that your eye got its image on your retina. When you look on far object, even your eye got its image on retina. Means what happened? When you looked on near object and far object, there is an automatic adjustment in your eyes focal length. That automatic adjustment is called the ability of your eye to get the images of those different bodies always on retina is called as power of accommodation of the eye. Have you understood what I mean to say? See, look here, as those ciliary muscles going to stretch or going to compress the eye lens, what happening? See how that focal length is going on changing. See, this is the biconvex lens. This is curvature. This is curvature. Okay? Yes. As we stretch that, when ciliary muscles stretching that eye lens, what happens? When they pull it outward like this, when they stretch the eye lens, what will happen? See here. When they stretch the eye lens means it going like this. Stretching means it going like this. What happening? You look on this curvature. Curvature is going on. Okay, curvature is going on. Increases like this. Curvature going on, increases. As curvature going on increases, what happening to the radius? Radius is going on, decreases. As curvature increases, radius decreases. One more formula you should know, that is 1 by f is equal to n21 minus 1 into 1 by r1 minus 1 by r2. This we call as lens maker's formula. Lens maker's formula. R1 and R2 are the radius of curvature of first surface and second surface. Biconvex lens. First surface, second surface. How they related? Even radius of curvature and focal length are directly proportional. Getting what I mean to say? As the radius of curvature increases, focal length also increases. See here how it is happening here. When ciliary muscles stretch the eye lens, that curvature going on increases. Curved portion going on increases. As this going to become curved, radius is going on decreases. As radius decreases, focal length of eye lens also going to decrease. When ciliary muscles are going to compress the eye, when they are going to compress the eye means curved portion, curvature going on. decreases. Curvature going on decreases. What about radius? Radius going on increases. As radius increases, focal length of the eye lens also increases. I mean what? By stretching or by compressing that eye lens, there is a change in the focal length of that eye lens. Okay, this going to happen automatically with the help of ciliary muscles. This we called as a power of accommodation of the eye. Okay, after this one. So now we have to understand one more thing is that we call as a visual angle of eye. Concept of visual angle of eye. What this visual angle? See, look here on this diagram. Look here on this diagram. Here again I have drawn the diagram of eye. This is eye. Okay, and this one is the biconvex lens. This one is biconvex lens. This is eye lens. Look, what happened? This is optical center of our eye. Okay, yes. And this is the principal axis. This dotted line is the principal axis. And this is the retina. This is a retina. Look here, what I mean to say. I already discussed about that one. Okay, eye has 2 points, near point and far point. If object is between these 2 points, then our eye can able to see its image clearly. Okay, fine. Look here. Here that object AB I have placed at position 1. I mean right now with respect to your eye, that object is at here. Okay, this is position 1. At that time, you just when you look on that object, here this is object. Our eye is like this. From that object, many light rays are coming and they passing through our eye lens. Just I am going to take one light ray which is passing through that optical center of our eye lens. Look on this light. This light from that object which is at position number 1. Okay, this light, yes, it came, it passed through the optical center and it passed like this. Okay, it got met here. What it means? See, many light rays are coming. Okay, I mean this is the light from the top portion of that object. Getting what I mean to say? This is biconvex lens. Now that top portion shifted here. Getting? I mean between this portion. Here in this portion we are going to get its image. Getting what I mean to say? Look here. I taken this light ray from its top portion and that beam here. Okay. Then between this portion, the image of that AB object is going to form on this retina. Okay. I mean somewhere here that image is going to produce. That I named as image portion on the retina. Within this portion of retina, its image is going to form. Okay? Yes. This much. For this one, the image portion is this much. Now look here. As you take that object near to your eye, as you take that object near to your eye, you look here what happening. Now you place that object at position number 2. Here it is, same object, same height object only. I mean same object. Place it now here. Again from its top portion you take a light ray, this light ray. Through that optic center, it will move straight. Their top portion is here. Okay? Their top is here. I mean now in the second position, the image is going to produce between this much portion. Previously was with this portion, now image is going to produce between this much portion of retina. What we can conclude? As object is coming near to our eye, the portion of image formation on the retina is going on increases. When object at position 1, its image portion is this much. When object came near to eye, its image formation got increased. Getting what I mean to say? Here you see what I mean to say. What is visual angle of eye? What means visual angle? Visual angle means it is the angle subtended by it is the angle subtended at eye lens. Subtended at eye lens by the image portion on the retina. Visual angle means it is the angle subtended at the eye lens, by the image portion on the retina. Means what? See here. When object was at here, then image portion is this much. This much portion is going to subtend some angle here. See here, look on this. This is a top light ray. This is a top light ray, and this is bottom light ray. Look here. Here that image is there. Here there is an angle. This is top portion. This is bottom portion. Here there is an angle subtended at the eye lens by this image portion. This angle we call as visual angle. Within this angle we can see that object. Getting what I mean to say? With this angle we can see that object. That is called as visual angle. Now you see, when object is placed at position 2, this is the ray from its top portion, and this is the ray from its bottom. Yes. Now that image is going to produce between this portion. In this portion. Now the angle subtended at the eye by the image portion is greater. Now this I named as beta. Previously it was alpha. Now I named it as beta. Okay. This we call as visual angle. Have you understood what I mean to say? Visual angle. Visual angle is the angle subtended at the eye lens by the image portion on the retina. Have you understood? Then one more thing we should know. As object comes closer to the eye, that visual angle is going on increases. When object is too far, then its image formed on my retina, and that portion of image made some angle at my eye lens. That we call as visual angle. That visual angle is less. As I take this object close to my eye, that visual angle is going on increases. Have you understood what I mean to say? That we call as visual angle. So now you see here, these two are very important. One was power of accommodation, then another one is visual angle. See now here, I already said, as we taking it close to our eye, that visual angle is going on increases. See, eye has 2 points, near point, far point. If that object which is coming close to our eye crosses that near point, okay, this is near point. When it was here, you can see, yes, you can see, and visual angle is going on increases. When it came at a D point, at that time you can see it very clearly. At that time visual angle also very high compared to previous positions. Yes. Now you can see, once that object comes between optic center and D point, in between, once that crossed with that D point, minimum limited point, then you will be seeing its blurred image. By having greater visual angle, as we approaching, as that object coming close to the eye, visual angle is going on increases, but up to D point you can see it clear. When it comes between optic center and visual, that D point, at that time visual angle is greater, but even though you are unable to see its clear image. Eye has certain limitations, it has certain conditions. Okay, now according to those conditions it is going to perform its function. So now this is about the eye. Now after this one, now we are going to enter into the optical instruments. See, optical instruments, many are there. Already I said eye is also one of the optical instruments. Okay, about that eye, here in your syllabus there is no much detailed explanation. Okay, they have removed that. Just here for your syllabus there are two optical instruments. One is microscope and another one is telescope. These two will be called as optical instruments. So what do you mean by microscope? See, to see the magnified images of small object. Okay, to see the magnified images of small object, we using one instrument that we call as microscope. The instrument which is used to see the magnified images of small objects called as microscope. Okay, this microscope is of two types. One is simple microscope and another one is compound microscope. You see here, firstly we go with that simple microscope. I already said what mean microscope. Instrument used to see the magnified images of small objects. Okay, simple microscope. Simple microscope even we can even call as a magnifying lens also. Okay, what it means? This is the ray diagram of simple microscope. This simple microscope is consisting one single biconvex lens. One single biconvex lens we call as a simple microscope. See here what happening here. Listen, just we have to take one single biconvex lens, and now with the help of that simple microscope we are going to get the magnified image of small object. See here, look on this diagram. Here it is a lens. Here I have mentioned capital F. Capital F is the principal focus point of this lens. Okay, and here also I have mentioned. Now here, okay, we going to get the magnified image of object, very small object. See, when you look on a small object, at that time you are that naked eye. Naked eye means without any help of optical instruments. Directly you focusing on small object. At that time your eye is unable to get its clear image. Okay, at that time that whatever magnification your eye is going to produce is not sufficient. Still, to see that small object clearly, we need help of some optical instrument, okay, like a microscope, simple microscope or compound microscope. See here what I mean to say. You have to take that small object very close to that eye lens. What I mean to say here this is the lens. This is the lens. Okay, you going to take that lens very close to your eye first. Getting what I mean? You holding that one in front of your eye like that. This is one simple biconvex lens. You taking that near to your eye lens. Now thereafter, what happening here? This is eye lens. Somewhere here, you going to take the object whose magnification you want. Here there is object. Here there is object. Here is your eye. Between that object and your eye, you taking that single biconvex lens, which we call as simple microscope. Getting? This is that small object is your eye. Between them, you taking that lens. This lens. You going to shift it like this. You going to move it like this. As by moving it like this. For one particular position, for that one particular position, you will be seeing clear image, clear magnified image. What you doing here? What you exactly doing like this? That we are going to understand with the help of this ray diagram. Getting what I mean to say? This is your eye. On your hand, there is a small object which you want to see it clearly. With your eye, you are unable to see it clearly. So you are going to get the help of this single biconvex lens, which we call simple microscope. You taking that between object and your eye, and you moving like this. As when you moving like this, at one particular position, you will be seeing clear image. What happened there? That look here. By this you will going to understand that. See, somewhere here, this is the lens which you moving. Okay. Behind that you are here somewhere. Here I mentioned the eye. Imagine it is closer to that. This is your eye. Here there is a lens. Here this is the object. Okay. AB is object. We want its highly magnified image. Highly magnified. We have already seen that a biconvex lens, okay, is going to produce both images, real as well as virtual image. Okay, here we want upright version only. I mean, here we want virtual, erect, magnified image. Okay, here we want same position of that object, not inverted version. We want virtual erect magnified image. Keep in your mind. To get virtual erect magnified image by the biconvex lens, we must and should take that object between its principal focus point and optical center. Get it? Try to get it first. To get virtual erect magnified image, that object we have to place, that object AB we have to place between its principal focus and optical center. Then only it is going to produce the virtual. That already we seen the sixth case when we are discussing about the image formation by biconvex lens. Okay? Yes. Now, I said you are doing like this. What you are doing here? You doing this means what? You taking that object doing. You firstly, okay, you are here. Your eye is here. Object is here. You see, not able to get that clear image. You taking lens. Somewhere you holding like this. And you watching through that lens. You will not get clear image. What you doing? You taking it up. You taking it up. I mean close to your eye. As you taking it up means that lens is moving away from the object. Getting what I mean to say? I mean this lens has its focal length somewhere here. Focal length, principal focus point. You doing like this means what? You adjusting like that. That object is going to come between